In this question, we're asked to find the entropy change for a particle in a system if the final number of microstates is 0.462 times that of the initial number of microstates. So this is actually a pretty simple problem since we're given the equation that we need to use. We're given that delta S is equal to KLN W final over W initial, where W is the number of microstates. We know that K is the Boltzmann constant per particle, which we're also given, and that is 1.38 times 10 to the negative 23rd joules per Kelvin per particle. And we're not given the final or initial number of microstates, but we're given that the final number is 0.462 times that of the initial. So we can just plug everything into our equation. We say that delta S is equal to 1.38 times 10 to the negative 23rd times ln, and we know that the final is 0.462 of the initial, and we'll call the initial just Wi. So W final is just equal to 0.462 Wi, and initials we can just say is Wi. So it may not seem like we have everything that we need in this equation, but we do, because we see that Wi just cancels out. So we're left with delta S is equal to 1.38 times 10 to the negative 23rd ln of 0.462. Now you can just plug that into your calculator. So calculating that, delta S is equal to negative 1.06 times 10 to the negative 23rd. And the units are, since this part of the equation is just a ratio, this is unitless. So the only units in the question are from the Boltzmann constant, which we find here, and that is joules per Kelvin per particle, which is exactly what the question asks for.